Hello science fans, welcome back to Science Fun with Austin. Today's episode is a viewer request from Dale in North Carolina who would like to know, is a Yeti cup really worth the additional price premium over an Ozark Trail cup? And we'll be evaluating that by looking at heat transfer. There are three main modes of heat transfer: conduction, convection, and radiation. Now, convection is basically from the fluid to the surface. That's going to be about the same for all the cups. Radiation losses are probably pretty negligible from a cup to room temperature. So what we're going to do is fill each cup up with ice water and see how long the cups manage to keep the ice cubes frozen. Okay, so to fairly evaluate the cups, we want to be sure we put the same amount of ice in each one. So we'll be tearing with this cup and putting the same amount of ice and the same amount of water in each of our candidate cups. Let's see how it goes. Okay, we've got 5.1 ounces of ice, and we'll add some water here. And we're at a total of 16 ounces of ice water. That'll be our sample for each cup. Alright, so now we have the Yeti, the Ozark Trail, my first enlistment bonus, and a memento from NDSU here. Let's see how they perform. Okay, so what we're looking at here is the outer surface temperature of the cup. If the cup was a perfect insulator, it would basically be room temperature. You can already see the cup on the end is not doing very well. But right now it's hard to tell the difference between the Yeti and the Ozark Trail. My enlistment bonus is almost but not quite as good. So the old Souvenir Cups on the right here just did not fare well against their more modern competitors. But we have a new entrant in the competition. So let's see how a clear double wall tumbler fares. Okay, so now we have the Yeti, the Ozark Trail, and a clear double wall tumbler. You can see the Ozark Trail is around 72 to 74 degrees. The Yeti seems to be in about the same range. The clear tumbler is doing better than the other cups did, but it's still noticeably cooler than room temperature, meaning that heat is entering the cup through the wall. Interestingly, if you look, the weak point on the cups is not the double wall stainless steel. It is definitely the lid. And in that particular case, the tumbler appears to be doing better. Okay, and we're about 3 hours into the competition. You can see both the Ozark Trail and the Yeti seem to have roughly the same amount of ice remaining. The clear wall tumbler still has some, which is better than the other cups did, but it definitely has less than the other two. Alright, science fans, so we've done quite a bit of testing, and it looks like it's really hard to tell the difference between the Ozark Trail Cup and the Yeti Cup as far as performance. But both of them do quite a bit better than anything else we've tried. And you might be wondering, how does a stainless steel cup resist heat transfer so well? And actually what we have are 2 layers of stainless steel with a vacuum in between, so that you actually have radiation from the inner wall to the outer wall. But you can approximate that as an effective resistance to heat conduction. And it turns out that that is actually pretty high compared with alternative designs. But it's probably more about heat transfer than you really wanted to know, but at least you learned that you can save some money on an Ozark Trail cup and get about the same performance you get from a Yeti cup. Until next time, see you later, science fans!